Welcome. Everybody's here to learn a little about the Sdlc today. Sdlc. Christy, you know what the Sdlc is?
No,
Guesses?
I don't.
Sdlc. So the Sdlc is actually a concept that people think of in different ways. The Sdlc. You look this up, I think Wikipedia or somewhere, you find the Sdlc is officially the Systems Development Life Cycle. So, systems, and I'll abbreviate to kind of keep things moving as we go. Let me know if you have any questions. Systems Development Life Cycle. Oftentimes we actually hear this from consultants we work with, that it's the software development life cycle. And that's not inaccurate, but the systems development life cycle is the higher level view. Because anything can be a system, including software. Software can be made to be a system. In fact, it usually is. What is a system? When you think of a system, Chris, what's a system?
Something that integrates and works together. Different applications or websites.
Sure, multiple
Different
components,
levels, yeah, and they all tie together.
things at large working together. Okay. I think a good way to define a system is its purpose. Why do we have a system? Typically, systems are created to solve a problem or to execute an idea. So systems are generally created to solve a problem or
Execute an idea.
execute an idea. Now there's many different ways we can go about creating a system, but typically it's best to have structure. So the Sdlc is commonly known, the most common Sdlc, the most common Sdlc is the traditional methodology that we often call the waterfall. Traditional Sdlc is broken down into multiple stages. There's a variety of different roles, and in fact, there's specific deliverables, or we'll call primary deliverables. So we're not going to go over every single deliverable in the system, but we'll go over kind of the high-level prime deliverables that we will define. Now the waterfall or traditional method is not the only Sdlc. So going back to the idea of building a system, and we'll just assume for the moment it's software, there's not only one way to do it. There's multiple ways to build systems and multiple methodologies by which we can execute that. So the Sdlc we'll dig into heavily today will be what's called the waterfall method. That's a traditional method. Most companies are using it or some version of it. But there's other systems that are becoming popular or have already become popular. We'll talk about those as well. Some of those names might be the Agile methodology, the RUP methodology. We'll talk more about that. So let's jump into the waterfall method. Let's get into that and kind of use that as a basis for some learning today. So, waterfall method we draw in a set of stages. That's visible the whole way down. And the stages we look at fall down a bit of a waterfall, right? That's why they call it the waterfall methodology. Each stage trickles into the next. So the most common way to break this down is we start with the beginning of a system, which is we have a problem, we have an idea. Right? We want to accomplish something. So that's stage number 1. You got an idea. Again, the idea could be a problem. Typically, we think of a system as an attempt to complete a project. I want to do something, I want to execute something, I want to go about executing a task or automating a task, oftentimes is the case. I'm going to use an example today we'll kind of walk through that's a very simple one that we're all very familiar with, and it's the concept of getting somewhere. My problem, we'll say, is getting from A to B. I need to go from A to B. So what do I want to do if I have this idea, I want to go from A to B, what do I first need to do? I gotta go from A to B. What do I have to do? It's the first step in thinking about how I'm going to go about it.
What time do you want to do it in? Where do you want to go?
Sure.
How do you get there?
Time, Okay,
much
you
it's
said
gonna
you said
cost.
when. Okay, yeah. Okay, there you go. You said time, and you said when. You said when you're going to leave. That's all time oriented, right? Then you just mentioned another important one. There's going to be a budget involved, right? The cost. Anything else you can think of?
How you're gonna do it.
How? Yeah, the actual means by which you'll transport yourself from A to B, right? So we'll just call that the scope. Oftentimes in a project, they refer to these three things as not necessarily cost. They use the term budget. And time oftentimes is actually called timeline. Start, the end, maybe any milestones along the way. And scope just means, again, how you're going to accomplish this. So you got to think about this when we go from A to B. Start to go through the idea of the idea that I have, my problem that I have, and review each of these concepts as it applies, and focusing on each of them as a whole. I look at the timeline and say, okay, well, I have to get from A to B. Those are my core concepts. That's kind of my scope at a high level. And I want to go. I want to leave at a certain time, right? So let's say I want to go from A to B in an hour. Do I now know how I'm going to get there?
No.
I need to get more information. And let's say that I know it's 50 miles away. Do I now know how I'm going to get there?
No.
We don't, but we have a better idea.
Yeah.
We
How
can
you want to get there.
We can start to think about means of transport, right? Like, for example, could I use a bicycle?
No.
No, because it wouldn't get me there soon enough. I couldn't ride a bicycle
In an hour.
in an hour to go 50 miles, right? Could I use an airplane?
Yeah.
I could. As long as I could get on the plane, get it up in the air, and get back down, it's probably going to move me more than 50 miles in an hour. It's pretty likely. Now, if I have to add another variable, and then we've talked a little bit about scope, talked a little bit about timeline in this example, we haven't really talked about budget, have we? I have a budget of $10,000. Do I have to eliminate any of the ideas we just talked about?
No.
Probably have to eliminate the airplane, I would guess. 10,000, I'm assuming we're going to build the system, right?
Oh. Okay.
Right? We could build a bicycle for less than 10,000, but it's not going to get us there. We could build a car, probably for less than 10,000, and we get there. So now you kind of get the idea of what we're doing, right? We're going through this process we call, any guesses? Sometimes there's a little extra serif or so in there. Analysis. We're analyzing the idea we have, the problem, whatever we're looking for in terms of a solution. We're going through this process of analysis. From there, we move on, and we've got to essentially decide which means that we're going to proceed with in our system, whether it's software or anything else, for the purposes of getting these stages out real briefly. The analysis of what we've done so far, we've kind of determined that some sort of a motor vehicle is going to be the best approach. So in finalizing our analysis, we might have also covered some other things like, is it just us that's going to go? But a minimum of 2 people. Well, I could still use a car. I could also use, might be a cheaper solution like a motorcycle. I could build a motorcycle. But maybe I need to bring cargo. How much cargo? Maybe with too much cargo, the motorcycle wouldn't work all that well. So in that case, I might have to decide, after my detailed analysis, picking out all of my specifics, at least all my details around my problem, my idea, I would probably decide on the car over the motorcycle. Once I've decided on building my car, I know kind of in general, I know in detail, I should say, what kind of system I want to build. But now I got to do the next step, which is to spec it out. Which means I got to take it and say, I've got this car, I need to actually design it. Design the car. Walk through each little detail. I like to use the car example because it's a great way to kind of differentiate these two stages. In the analysis stage with the car, we're generally thinking of, okay, I want to make sure the car fits more than 2 people or 2 people at minimum. I want to make sure it carries cargo. It's got to have a steering wheel because I need to drive the thing, right? And I want a 4-wheel car, not a 2-wheel motor vehicle, right? Because that would be a motorcycle. So I've got all these kind of basic principles around which I want to have my solution work. The design goes real deep in that sense. Like I would say, I want this steering wheel to be exactly 16 inches around, right? It's got to have a 1-inch diameter and some odd circumference on the handle of the steering wheel, so my hand could use it effectively. I want it to be leather, right? And that leather needs to be grade A, and that needs to be exactly 2 millimeters thick. You see the level of detail we can get to in just the steering wheel. But that's where we get into the system design, car being our system, the very detailed level of specifications we're going to create for the system. Idea analysis design. What do we do after that? We've got our idea, we know how we're going to approach the idea, we've got specs to execute the idea.
You gotta build it.
You gotta build it. You gotta build it. We call this development. Development. We're gonna now go ahead and build our system. So build the system, that's pretty straightforward, right? In the case of the car, we just start putting nuts and bolts together and eventually come up with what we intended from our design. And now what do we do?
After you build it, you have to see if it works.
You gotta see if it works. So what do you hand it over to the customer?
You test it.
You gotta test it. We gotta make sure before we give the keys out to the person that's gonna pay for this system, you gotta put the rubber on the road, right? Give this thing a spin, make sure the wheels don't fall off, make sure it gets from A to B, right? That was our original idea. It's gotta actually go from A to B. This is a great example with the car because in situations like this where we do the development, we may not have anticipated that at some point we're hitting dirt road. And maybe we put slick tires on it because we wanted to go fast. Well, we hit that dirt road and we spin out of control on the test. So we better go ahead and make some adjustments. We gotta make some modifications to our system. And so it might have sometimes, oftentimes, you'll come back after testing it and do a little bit more development. In fact, in some cases, you got to go all the way back and do some more analysis. Oh, there's some dirt road there that we didn't think about in the process. Let's design a solution for that particular component of the system, build it, get some new four-wheel tires, and now let's go test those on that dirt road. And assuming you don't run into any lakes along the way, you should be okay, right? All right, so now we've tested the system. We feel pretty good about it. It's ready to go, about to hand the keys to the customer. What do we do?
You have to approve purchasing or implement.
You fire it up and you hit the road.
Okay.
That's it, literally.
So
You
implement.
You implement it. Thank you. Implementation. Yeah, you're a step ahead. Christy, you're making everybody else look bad here. Implementation. Implementation. That's where we're going to go ahead and implement the system. Put it into the real world. Go live, oftentimes, especially in the software world, you hear go live. Okay, well I have one more little line down there. What is that for?
Just to check to make sure if everything went well.
Yeah,
And
yeah, that's a fair
follow that.
synopsis. But the stage, we call it maintenance. Right, we got to maintain the system. Cars are a great example. Again, we have to do regular oil changes, right? That's maintenance as pure as maintenance gets. Something we might not think about as maintenance, but it's planned maintenance. It's regularly refueling by way of a gas tank, or today we often use electrical vehicles, right? So you need to continuously give this system what it needs, whatever it may be, oil change or fuel. And occasionally you'll also have to do not just regular planned maintenance, but what we would think of as a defect fix, right? So kind of troubleshooting errors that a customer, the client who's taking this system out into the real world finds that you didn't discover in testing. I mentioned a lake. Maybe we didn't plan for rain. We never tested our system in rain, and all of a sudden it starts raining, and we forgot to put a top on our car, right? Well, that's a bug fix, right? I mean, if we sold this system to work in any A to B scenario and it doesn't have a top, and now the material, the interior materials are starting to wither and become problematic, it may be cheaper than replacing all that stuff for the customer, then just come up with a new solution, and an add-on would be a top to the car. That's maybe implicit, but you've seen, I'm sure, as a consumer in the real world, many times you get a notice for recall of a car for whatever means, right? Because they want to fix that bug so it doesn't cause that same error for other customers. Right. Look pretty good? Excellent. So that's the idea of stages, right? But each of these stages, we have to have people to execute them, right? There's going to be roles that contribute to this. And this is extremely relevant when it comes to our business, right? Because we are the people selecting the consultants that are going to do this work. So, the idea. Who is responsible for the idea? Well, we think of this person as sort of the owner. They generally own the idea. Oftentimes they own what's called the product. A car is most definitely a product, and even in the software world we deal with often, they think of the software solutions, the systems they put in the real world as products. So in that sense, this person responsible for the idea is referred to as the product manager. Product manager. Again, for the sake of expediency, we'll abbreviate as we go. Product manager. So the product manager is going to go and come up with the idea. He's going to pass on his idea and some of his deliverables, which we'll talk about in a moment, his or her deliverables, onto another team. And that team, any guesses who handles the majority of the analysis stage?
QA.
Not quite yet. It's similar though. It is going to be an analyst of some sort. It's typically referred to as a business analyst. Business analyst. So we have the product manager who comes up with an idea, has a problem, wants to bring some solution to market as a system, passes off his deliverables to the business analyst, who's then responsible for executing the stage of analysis. And then from analysis, we've now got, let's say, a good concept of our system and how we're going to approach it. We then have to spec it out, as we've said a couple times, and we pass that off to another team, similarly named the systems analysts. Now pause for a moment here and point out that these aren't the only roles in each of these stages. You're going to find that as we go through the process of managing resources and selecting individuals, consultants for our projects, each of these stages will have sometimes multiple people. We're identifying what we call the primary role responsible for the stage. There is one in this particular stage worth pointing out. Oftentimes, in some capacity, there is an architect involved. Architect. Writing too fast there. Architect, and that architect, they'll bring to the table perhaps not so much specific deliverables, but given their expertise in working with systems, they usually are more experienced individuals as we kind of select a resource for this type of a role. They're going to know best practices in delivering systems. Okay? So they go ahead and come up with a design, they spec it all out, hand those specs off to who?
Java developers, JavaScripters, any kind of
Developers, right?
Yeah.
Depending upon the system, you bring up a great point, Christy. It could be Java developers if it's going to be a Java-based system, but it could also be .NET, right? You mentioned another scripting language which is similar to Java, but not quite the same. JavaScript. It could be a JavaScript development effort for, let's say, a user interface-heavy dynamic website that they might be building, or web application. But the ultimate focus there is, regardless of what type of developers, they are developers. Developers. I leave room here because I want to also mention, sometimes we generically hear these called engineers. Developers, engineers, and even there was a time, back when I was a coder for a short while, we call these programmers. Because they would create programs, software, right? All right, so moving right along, we've got the idea of these guys building the system, coming up with what we call sort of the raw system, and we move along to the next stage. We're going to test it. Who's responsible?
QA.
QA, right? QA. What does QA stand for?
Quality assurance.
Right. Oftentimes you see SQA, which stands for Systems Quality Assurance. Again, not software, but again, sometimes people confuse the idea of Sdlc being a software development lifecycle. So it's interchangeable, to be honest. Software quality assurance, systems quality assurance. They're going to be testing the quality and assuring it that when the customer, the client, when anyone puts it out to the real world, that it's functional and working. All right, so we've got a system, taken it from its raw form, tested it, and now what do we pass it off to the folks who are responsible for implementation? Who are those folks? Any guesses? This is a tough one. This is another one that's worth writing down a few roles because we'd say the primary one would be the systems administrators. And this is really, kind of generic. It could be anybody who's administering it, like, and then going back to the car briefly, the guy turns the key on and then, drives it out to the dealership or loads it up on the truck and puts it out for the sales efforts that go on in dealerships. So in the software world, we call it a sysadmin pretty regularly because they're the ones literally taking software that's been developed and tested and now putting it into what we think of as a computer, right? We get computers all around us. They're the ones who literally load the code, or oftentimes we use the word compile. These guys are going to compile the code, build the code, and then load it into a system such that it can be utilized on some sort of interface, typically a web application. Or it could be a desktop application like we use every day, Microsoft Word, something like that. These are the guys who take it from a bunch of sort of code mumbo jumbo that some of it's English-like, we may or may not be able to make complete sense of it, and they put it into an interface for us on we often call a box, on a system, on a computer or a server somewhere. Okay, so we've got that system working, it's out in the real world, it's been implemented by these guys. What do we do next? We maintain it. Who's responsible for that? Support, right? Support, and that could be in any capacity. It could be help desk support if it's an application that needs a lot of guidance, customer service type stuff. Oftentimes we're thinking more along the lines of the system itself having bugs, so that would be a role that we hear called a PSE, which stands for, any guesses? Any guesses?
Systems engineer?
Close. S is for support. P is for production. It's a common term we use, and again, this is real software specific. The production support engineers, the PSEs, they're the ones who are actually supporting the code that's driving the system, and when a bug is discovered, there's got to be some modifications to the code. So these are generally engineer type folks who understand code, be it .NET or Java or whatever Python is being developed. And they are able to support that code by making small changes or adding a line or finding a query that's going to the database and it has an issue. These guys are responsible for that, those kinds of fixes, and or escalating it back to the cycle here if there's a major change like putting the new roof on, right? That would be a bigger effort. Speaking of the car analogy. So production support. Production is an interesting word. It's kind of nice to take a second to think about that. And I said I would identify some further roles here. It goes into production. What do we think of when you think of production? It may be a little bit confusing, right? A system that's in production is, in the software world, is done, but often when you think of production, it's being created, right? And the reason that we use that term in the software world for a live system is it's much like a machine, on an assembly line. So if you think about a machine on an assembly line, what does all the work go into it from the humans who actually create the assembly line?
Manually putting tires on,
Well, step back. I mean, so assume it's a machine that has little to no human interaction, right? Or think of an assembly line, right? Once I do what? I hit go, what do I do?
Nothing.
I sit back, right? And I watch, right? But what's happening is I'm producing. Let's just, tortilla factory, right? We put all the flour, we load all this stuff in there, we hit the button, it says go, and then we sit back, we relax, and watch the tortillas just roll out into a stack, right? If it's an advanced machine, it might even package them for us. So the concept in the software world is similar because they go through all this effort to put this assembly of components for this system to work, and then they put it out in the real world, and they sit back and they watch the cash roll in, right? That's the concept. They sit back and they watch this system do whatever it's supposed to do, to automate a task or execute something that will generate revenue. Okay, the folks who are responsible for putting it out there, I said at large, are sysadmins. We also see some other skills that sort of blend into this a little bit. We'll hear these often in our efforts of selecting resources for projects. We see build and or release engineers. As systems have gotten more sophisticated, more complex, a lot of these roles have broken down where you might have had just a single sysadmin at some point. You might have multiple people now in just a build release engineer role in addition to one or two or three or many sysadmins depending upon the complexity of the system. Okay, we've covered all the roles. Any questions?
No.
Okay, let's take a brief pause, break, come back and go over the deliverables.